So in today's lesson, we're going to continue our conversation around binary compounds, and we've discussed all of the binary ionic compounds those are those with metals and non-metals. So let's take stock of where we are so far. So if we're looking at all compounds, and you happen to look at the formula for a compound and you see that it's composed of only just two different types of atoms, two elements, then we know that we call that a binary compound. And, binary compounds can be made of metals and non-metals, or they can be made of, two non-metals. But right now, so far, what we've learned is we've learned about compounds with a metal and a non-metal, with only one possible charge, right? We call those monovalent metals. And then we also have those metals that have multiple possible charges, and we call those multivalent metals. And that's where we're going to use those Roman numerals or those Latin names for those of you that went on to learn this, those of you that are taking grade 11 chemistry next year. Okay, but let's go back to binary compounds. We've covered the whole ionic bit, the metal, non-metal, but what we haven't talked yet are about how the heck do we name compounds with two non-metals, right? So the purpose of this particular lesson is to talk about the rules around non-metal IUPAC naming and why the rules are what they are. Okay, so let's first look at the periodic table and remind ourselves what it means for compounds to be molecular or composed of two non-metals. We're looking for elements that are on the right of that staircase line, okay? All to the right of the staircase line. So if you see a compound that is binary and contains two non-metals, then the rules that we're about to learn are going to apply to that situation. Okay, so we know that compounds with two or more non-metals are called molecular compounds, but in this case we're looking at binary molecular compounds because we're looking at compounds that only contain two different types of atoms. Okay, so now we're not going to use the crossover rule here, people. Okay, and why are we not going to use the crossover rule? Because there are no ions that have been formed in this situation. We use the crossover rule when we describe ionic compounds because we're looking at elements gaining and losing electrons, right? Becoming cations and anions. And so in that case, those elements have charges. That's when the crossover rule applies. But when we have two non-metals together, we're looking at a situation where those elements are actually sharing electrons. So no electrons are lost and gained. And so we can't really use the crossover rule. And so I'm going to go into this a little bit more in grade 11, but because ions are not formed, we have to have a different way to decide to tell the reader how to name the compound or how many of a particular atom are in that molecular compound. So we're going to use these prefixes as a way to let the reader know how many of each atom are in the compound. So let me explain a little bit more. Okay, so for example, let's start with a compound you should be fairly familiar with, carbon dioxide, right? Well, carbon and oxygen are in carbon dioxide, and they're both on the right of the staircase, right? They're all over here, so they're both non-metals. So we're not using the crossover rule here. And so carbon dioxide, that di that is there, is it's letting the reader know that there are two oxygen atoms. Okay, so notice I did not use the crossover rule here. Okay, here's another example, dinitrogen pentoxide. And so the name in this case, okay, the di and the pent are telling me how many of each atom are there. Okay, so we're going to talk about these prefixes and how they tell us a certain number in a little bit, but these are just sort of precursors to get your juices flowing. But notice that both nitrogen and oxygen are to the right of the staircase. They're both non-metals. And so if I were to see this chemical formula, what that would indicate to me that I need to use prefixes because, of course, the crossover rule doesn't really work here. Okay, let's keep going. So I want to talk to you about these prefixes. And so set up a little bit of a table for yourself. We're going to go with how many atoms we see in a formula and what the prefix in the name needs to be. So first of all, let's start with 1. So if there's one of a particular atom, then we're going to use the prefix mono. And we saw that when we looked at mono and multivalent metals, right? So mono means 1. I want you to think about with 2, that being di, And now before I go ahead and reveal what prefix we're going to give, if we have 3 of a particular atom, I want you to think about and make a good guess. So I'm hoping that you guessed if we saw 3 atoms in a particular molecular compound that you would give that particular atom the prefix tri. 4 is a little tricky. So 4 is actually tetra. And I usually explain to my classes, well, that's why Tetris, the game that we used to play years ago, each block in Tetris is made up of 4 different blocks arranged kind of in different orientations and configurations. So 4 means, tetra means 4, and that's why Tetris has 4 blocks in each shape. Okay, 5 is penta. And so I want you to think about what 6 might be. So I'm hoping you guessed that 6 might be hexa. So some of these, prefixes are, they come up in other places, right? Like a pentagon and a hexagon. And so, that may help you to remember these prefixes, right? So like a pentagon has 5 sides and a hexagon has 6 sides. Okay, 7 is one that students tend to forget. Okay, 7 is hepta. Okay, the one thing that may help you, it's kind of sort of related, is the French word for 7 is sept, and this is hept, so that's sort of similar. Okay, 8 is octa, as in octagon, the 8-sided figure. I'm going to go through 2 more. Nona, and that's one that students sometimes forget, but luckily it doesn't come up too often. Okay, what do we call a 10-sided figure? That's going to help us remember the prefix given for a molecule containing 10 of a specific atom, if we're talking about a molecule and not an ionic compound. And that's deca. So there they are. Hopefully you did okay with that. Some of these are familiar, maybe 3 of them. You might have to, make some flashcards out and try to remember them. Now, I'm going to just briefly mention this. This is a rule that I'm not going to test you on this year, but it will come up in grade 11. The prefix mono, we usually omit or leave out if there's only one of the first atom in a formula. That's a bit wordy, so let me kind of provide an example for you. So carbon monoxide. Notice that there's one of the first element and one of the second element, but we didn't call this monocarbon monoxide. We called it carbon monoxide. So we left out the mono because when there was one of that first element, but we don't leave it out if there's only one of the second element. Not sure why, but that's just the rule, right? In the same way that carbon dioxide is not monocarbon dioxide. Okay, so the next little bit I'm going to just kind of explain to you, but we're not going to be tested on this year. So just, it's more of an FYI for this year, just so next year if you're taking grade 11 chemistry, it won't be completely new. Oh, sorry, nope, I was going to talk about that later, but I'm going to sneak in some examples first. Okay, so try these examples on your own to check for your own understanding. If I said to you, provide the formula for each of the following, what would you give? Okay, so these are mandatory. You do need to try these and understand this. It will help you when you're working through the worksheet. So give these 2 examples a try and see how you do. All right, so I'm going to take a look at this first example, xenon tetrafluoride. So again, these are great because the molecular compounds, you actually don't really need your periodic table in front of you, except maybe to locate the element symbols, but you're not looking at charges because we're not forming any ions in molecular compounds. So xenon is a noble gas, and you might be like, well, why is that forming compounds? Well, I kind of hinted at that earlier. Sometimes it likes to do that, but we would never really know that if we had to try to apply some kind of a crossover rule. So xenon. So the fact that there is no prefix there is telling me that there's only one xenon atom in there. And this prefix tetra tells me that there are 4 of the element that comes after that prefix. So tetrafluoride means that there are 4 fluorine atoms in this molecule. Hopefully you did okay with that. If not, hopefully that made sense. And in the next example, you'll be better able to maybe give it a try and have some luck. So tetraphosphorus decoxide. So tetraphosphorus. So tetra, as we saw in the last example, meant 4. So that's telling me that this compound has exactly 4 phosphorus atoms. And then I look at the next part of this, and it's saying decoxide. So dec is a prefix meaning 10. So decoxide means 10 oxygen atoms. And I'm done. And I just want to briefly remind you that in molecular compounds, we do not reduce to lowest term. Why? Because in molecules, the number of atoms that are shown in the formula tell you the exact number of pieces that are bonded together. So in other words, this molecule would have exactly 4 phosphorus atoms bonded in a certain way to exactly 10 oxygen atoms. Okay, so I would like for you to now attempt to name the next 2 compounds. And there we are. Give those a go, and then when you're ready, resume the video. Okay, so when I look at A, I'm seeing that there is 1 of the first atom. And so 1 of the first atom means I don't need to include any kind of prefix. I'm just going to say sulfur. And then I look at the number of the second atom, and I can see that it's oxygen, but there are 3 oxygen atoms. And just to backtrack a bit, before I even name these, I'm evaluating, well, what type of compound is this? Is this ionic or molecular, right? Is it made of a metal and a non-metal, or 2 non-metals? Because again, the only time we ever want to use these prefixes is when we have a molecular compound made of 2 non-metals. So this is sulfur, and I have 3 oxygens, so sulfur trioxide. Okay, hopefully you did okay with that. Now I'm going to look at the next one here, and I see again that there is only 1 of the first element, so I'm going to say phosphorus. And then I'm going to look at how many of chlorine atoms I have. I have 5 of them, and I'm going to remember that prefix for 5, and the prefix for 5 is penta, so this is just simply pentachloride. Okay, and that's it. That's all, folks. Okay, so if you are not taking grade 11 chemistry, you can kind of just tune out at this point and just kind of carry on with your life. But those of you that are taking grade 11 chemistry are going to want to listen to the next little bit. Though you won't be tested on it, you will need to remember it. So this last little conversation has to do with hydrogen. And hydrogen's a bit of an oddball, right? Because we know very well that hydrogen is grouped in group 1 along with the other alkali metals, yet it is not a metal. It is a non-metal for sure, right? So, because it has 1 valence electron, it's grouped in with all the other alkali metals. Still, though, having said that, it acts like a non-metal in certain circumstances and as a metal in other circumstances. And so that means that the naming for compounds with hydrogen becomes a little bit problematic. So I want to kind of explain to you some of the basic rules. So yeah, just give me a second to get to the right slide here. So here we go, rules for hydrogen. So hydrogen first in the formula. Okay, remember that cations always go first in the formula. And so if hydrogen is first, then it's going to act as the cation, right? We're going to think of it like an ionic compound, and we're not going to assume any prefixes. So for instance, H2S, in this case, hydrogen is first. We would call that hydrogen sulfide. Okay, if hydrogen is second in the formula, then we would consider it being as a non-metal, and we would use prefixes. So for example, CH4, this is methane, but another name, IUPAC name for it would be carbon tetrahydrogenate. hydride. Okay, the tetra there is telling you that there are 4 of them, but we're placing that hydrogen second, and so that is how we name it, as we're considering it to be a nonmetal because it's second. Okay, lastly, hydrogen with a metal, but as an anion, then again, if it's in an ionic compound, we're not using prefixes, okay? So just remember, if it's first, it's acting like a metal, and if it's with a metal, it also has to be in an ionic compound. So NaH, in this case, the hydrogen is second, but it's paired up with a metal, which means that it is ionic. So this would be sodium hydride, okay? So you know what, this is a bit detailed given our current circumstances, so I can completely understand if this is like beyond what you're capable of processing in these times, but it may seem, may jog your memory next year when we take this up again, if you're taking grade 11 chemistry. So now what you should be working on is the worksheet where you are practicing the naming rules for binary molecular compounds, and you can find that in our week plan.